We are asked to interpret equations graphically. So here's our function, f function, natural log of the t plus 1. And then we have an h of t function that's a quadratic. The highest power is 2 here. The graphs y equals f of t and y equals h of t are shown below. So we can see here's our parabola from the quadratic, and natural log has this type of shape. So those are from our parent functions, just sort of knowing in general what they look for and look like. Which of the following appear to be solutions of this? Notice they are equal to each other. When they are equal to each other, that means they're sharing that same output or y value. So notice that we have a shared y value at this point here, and we have a shared y value at that point there. So when we look at it, when it says a solution, it's talking about what would usually be like the x value. In this case, they're using the letter t. So I see that showing up a few times here. So a solution is going to be a t value. It corresponds to the x value or the input when they ask for a solution. So the t values for those points are t4 and t3. So choose all that apply. Okay, so we want t4 and t3. t3 and t4. We'll check our work. Got it. Let's go ahead and try the next one. These are solving equations graphically. So this one, you want to use the graph. We can solve this algebraically, but it gets real muddled and complicated really quick. So here's our function, f of x equals, that's a half, x squared plus 3x minus 2, and then here's our g sub x function. We got an absolute value, and that's what makes this thing more muddled, is that breaks it up into a piecewise format. So we'll go ahead and deal with that piecewise aspect later. But right now, all we have to do is do it graphically. So the first thing, use the interactive graph to sketch the graph of g sub x. So g sub x is a absolute value. So when doing absolute value, we think about the parent function. So here's my parent function, the absolute value of x. So the absolute value of x has that sharp kind of corner of where it changes. So it's y equals x on this side and like a y equals negative x on this side. So that's our parent function. And then if we wanted to expand on what the parent function kind of changes, there's some scale factor in front, x minus h, and then we have our plus k at the end. And this affects the x, so that moves it left and right. And I always think about it as the opposite of whatever that is. It's an opposite movement. Because why? We have the negative right here. So whatever that number is, to me, I just mathematically and logically think of it as an opposite movement, left and right. So, and that's our x on that one. So left and right on that. And then our k is y movement. So that's your up and down movement. All right. And then the number in front is that scale factor. It makes something bigger or smaller or flips it. So notice right here we have a negative sign. So that's going to flip it. And then I'll go ahead and adjust it with the left, right, up, down motion. So what I like to do is we think about what happens at like kind of the vertex, or I call it like an important point, an inflection point. So for this one, we want it to, okay, so here are our choices right here. So notice absolute value is this one. The other ones have that same type of form that I showed you earlier when kind of talking about these. So it has that same type of form. There's a number outside that kind of scales it and makes it bigger or smaller or flips it. We have the effect directly on x, and then we have the effect directly on y there. All right, so we are dealing with this absolute value function. And I like doing my x first. So this is a negative, it's positive 3 here, but I go to the negative 3, and then that's positive 4. So I do positive 4. So that's the kind of the inflection point or the vertex, so to speak, on this absolute value. And then the negative makes it go upside down, and then it has that normal behavior, that normal slope behavior, since there is no scale factor other than flipping it from the -1. So that's how the graph would look. And then, so that's the interactive graph, check. And then what does it want? Let x1 and x2 be solutions. So remember, a solution is the x value when x is solved here. And they want the one where x1 is smaller than x2. All right. So when I look at this, here's one of them. It's not letting me draw on it. So there, that one right there, if I could draw, it'd be right there. And then we have one on this side over here. If I could draw on it, it'd be right there and right there. So which one is less than the other? Where x1 is less than x2, we wanted the x1 value right there. So we want the one that's smaller. So the smaller x value is going to be this one right here. We just got to be careful. It helps us too to kind of note this has a positive x value. This has a negative x value. All right. And then they want an estimate of the x1 value. Answers within 0.5 units of the solution will be accepted. Because we are doing this graphically, we are pretty much estimating what's going to happen right there. So my recommendation, since we can do this graphically, is just use the best kind of grapher we have on the computer. Best type of grapher we have is Desmos right here. So here's our f of x function. There's our parabola. Here's our absolute value function. And the good thing about it is they've already marked out what the values are. There we go. And it looks like the x value right here is negative 6.69. Okay, negative 6.69. That's what we want. And let's go back here. And it is negative 6.69. Let's see. Yay, we got it. All right, so that's how we kind of do these. My recommendation is use yourself a good grapher. Otherwise, you have to kind of estimate what the x is. Even though, graphically you're estimating, I don't mind estimating if it's like kind of on a coordinate cross, but I really don't like if I can avoid it estimating when I don't know what that point is.